Hello everyone, thank you for being here. Today I will talk about one of the foundational technologies of the internet, how devices get identified, connected, and how data travels by comparing IPv4 and IPv6. So let us talk about the differences and the working of it between these two components. Let us understand with internet protocol, like what is it. Internet protocol is the fundamental communication protocol that assigns unique addresses between the devices, which data routing across networks worldwide with postal system of internet. So every device requires an address to send the receiving information. IPv4 was introduced in 1983 with 32-bit addresses, powering the early growth of the internet. As the digital landscape expanded exponentially, IPv6 in 1999 was launched with revolutionary 128-bit addresses for future-proof connectivity. The numbers matter, whereas IPv4 32-bit address space providing approximately 4.3 billion unique addresses, infinite in 1983, whereas IPv6 were 340 undecillion. Let us understand between the address format and naming differences between these two. IPv format, numeric decimal notation, 4 numbers separated by dots, whereas IPv6 format, alphanumeric hexadecimal, 8 groups separated by colons. Example 192.168.1.1. An example between IPv6 is 2001 colon 0 dB, etc. Whereas range of IPv4 is 0 to 255 per section. As IPv6 zero compression for shorter, cleaner addresses. It's whereas IPv4 is easy to read but limited capacity. IPv6 format more complex but infinitely scalable. The pro tip of IPv6 is zero compression feature allows consecutive group of zeros to be replaced with colon, double colons, making long addresses more readable and manageable for network administrators. Let's talk about this one, header and the packet structure between these two. Whereas IPv4 header requires 280 to 60 bytes with complex multiple feeds, includes checksum, verification, but its slower processing requirements compared to IPv6. IPv6 header is fixed length of 40 bytes, no checksum in main header, but slightly faster than IPv4, whereas comparison of between IPv4 and IPv6. Extension headers for flexibility. Let us talk about the key functional differences between these two, IPv4 and IPv6. Let's start from the address configuration. Requires DHCP, the dynamic host configuration protocol, whereas in IPv6 supports SLAAC, stateless address auto configuration. Whereas in communication methods, IPv4 uses broadcast, multicast, and unicast. IPv6 replaces broadcast with efficient multicast and adds anycast for intelligent routing. For security architecture, IPv4 is optional and implemented inconsistently across networks. IPv6 built-in mandatory. Transition challenges and coexistence. Dual net stack networks, whereas IPv4 and IPv6 run simultaneously on the same infrastructure, allowing gradual migration about without device service disruption. Tunneling techniques. IPv6 packets encapsulated with IPv4 packets. Traverse legacy, adoption barriers, legacy device compatible network complexity. The period requires careful planning and significant investment. Organization must balance maintaining IPv4 compatibility while implementing IPv6 infrastructure. Future is IPv6 why it matters because unlimited addresses, enhanced security, better performance, simplified management compared to IPv4. Because global IPv6 adoption has reached over 38% worldwide, with technology leaders like the United States exceeding 50% deployment, major cloud providers, ISPs, and enterprises are driving the transformation. IPv6 is no longer optional, it's essential for building a scalable, secure, and truly connected future. Thank you. So let us understand through the simulation between the two components of IPv4 and IPv6. So let us start the simulation. So yeah, this is an IPv4 and IPv6 model. So IPv4 requires two switches, switch 1 and switch 2, and two routers, router 1 and the router 2. The message passes from the switch to the router to the router again and the switch and receives at the destination from source to destination, whereas IPv4 is around 4.3 billion unique addresses, and it requires a technology like NAT where multiple devices inside a network share single public IP address that helped extended IPv4, whereas in IPv6 it doesn't require a NAT technology because it has like vast addresses as compared to the IPv4, whereas it can store lot of addresses and many other things. So basically let us in a simple way, whereas IPv6 has more capacity and more address space compared to the IPv4. In the IPv6 there also the same setup, two switches and the two routers, source to destination, and this is the whole model. And you can see the summary of the common path from PC to switch, then router to switch, and data forwarded and acknowledgement back of PC to, whereas acknowledgement used to receive from the again from destination to source. That acknowledgement is basically a thing where the data have been reached at the destination. It just send an acknowledgement that of the particular thing. So yeah, that's the main thing. Again, I'll play the simulation. This is the summary basically. Here you can see the this one is not playing. Yes. Again, I have to restart. I guess yes. Restart. Play. Here you can see the message. The message from transfer in the form of packets through switch through router one and router two to router switch and reach to destination, and the acknowledgement sent back to the PC1 to source that the packets have been reached. The message has have been reached. Even the same thing in IPv6, but is an advanced version of IPv4 compared to. It was actually launched in 1999. This was in 1980s. Here you can see the packets transfer from switch where I fast a bit. See here you can see the series traveling through the routers and switch and reach to the destination. And the packets and the acknowledgement again reach back to the source. Here see the acknowledgement have been reached back to the PC1. Yeah, this is the summary of the whole part, how it works. Thank you for being here. Thank you.